Hello all, my name is Naveen. Uh, I am third year student of electrical engineering. Today our topic is study of application of autocorrelation function for analysis of signal. The main objective of this experiment is computing pulse rate from a PPG signal and pitch period of a speech signal using autocorrelation function in a real-time Arduino prototype platform. Use both offline and real-time test signal. And here first one is for PPG signal by assuming sampling rate of 100 Hz and resolution of 10 bit and frame duration of 5 seconds to complete the pulse rate from a PPG signal. And second one is speed signal. Frame, assuming sampling rate of 8000 Hz and resolution of 10 bit and frame duration of 30 milliseconds to complete the pitch period from a speed signal. Here mainly what is autocorrelation? Autocorrelation represents the degree of similarity between a given time series and lagged version of itself over successive time intervals. Autocorrelation measures the uh, relationship between a real variable current value and its past value, right? So, if you so what is the difference between correlation and autocorrelation? Autocorrelation function of a signal is defined with respect to the signal itself, whereas the correlation function of a signal is a correlation of two independent signals with a time shift in of the two independent signals. And why we have to find autocorrelation? Like autocorrelation function is used to find the period of the signal buried in the noise. So this is important, and some of the properties of autocorrelations are uh, autocorrelation is a symmetric and consistency. Autocorrelation for periodic function is also periodic with a similar signal, right? So here is a procedure to compute the autocorrelation function for each frame. This is the expressions for autocorrelation. Rm equals to 1 by r of 0 summation of n equals to 0 to n minus m minus 1 x of n into x of n plus m. Here m is length of the filter. By finding maximum amplitude of autocorrelation function and locating first zero crossing point. Okay, this is the procedure to how to follow, and now we will see the code. Okay, open the Arduino software. This is the code which I was already written. Here we are given the samples of 2000, and these are the declarations of our code. Here m equals to 8 is the length of the moving average filter. These are all the declarations. Serial dot begin 9600, and here the loop while loop. First we are dividing signal into blocks. The signals into blocks like this. There are 2000 samples, right? We will dividing 500, 500, 500, 500. So we are dividing signals into blocks, and this is called for moving average filter. So this is input signal, and we input signal after dividing into blocks, we will implement in moving average filter for smoothness, right? Okay, this is a code for average of signal. We will do mean. We will do the average of the signal, average of this moving average signal. After that, like this is for removing mean and calculating autocorrelation at a time. See, if you see the standard expression of autocorrelation, like Rm equals to 1 by R of R naught, R naught summation n equals to 0 to capital N minus M minus this one. See, that expression is normalized autocorrelation function, which I have also written here. Here p is like 1 by R of 0. Here this is for finding the location of zero crossing point. And signals, what we'll do is I will explain in output actually what is happening. So first I will connect Arduino board to this my Lappy and just verify the code if the code is correct or any syntax error, and done compiling, and then upload this code. And then go to tools, serial plotter. This is the output. See, this is the input signal which we have passed, right? This is the input signal. This is the output which we have. Why we have used autocorrelation? Because it is used to find the period of a given signal, right? See here, this is the first zero crossing point. First zero crossing point up to here. Here to here, this one is maximum location to here. So by adding zero crossing point distance and this local maximum, we will get the time period. Okay. For one cycle, it's take NTS. For 60 seconds, how many? This is so. This is the output. To find that beats per second, what we should do? We should do uncomment here. Uncomment. Then verify. It's uploading. Done upload. Now go to serial monitor. Here we will get beats per minute. This is for PPG signal, and I have told, and we have to find that for speed signal also. What for speed signal? What we'll do now? Instead of giving here 2000, instead of giving here input signal, we will give signal has speech, our noise, like 1 second, hello, hello, like this type of noise we will give as input signal. And the code is same declaration, and we will that signal is passed through moving average filter, and we will do the average of signal. And then after it will then removing mean and calculating autocorrelation function at a time. Then after normalized autocorrelation function, then again uploading the code in Arduino board and finding the location of zero crossing function and signal starting point from zero crossing point. Okay, and then again we will add both the zero crossing function, zero crossing point plus local maximum, that maximum location. We will add both the distance, and we will get the period of the signal. Right. Thank you all.